Welcome to iLectureOnline, and here we're going to do a real life example of how we deal with rigid body rotation. And this is going to be about a tire as part of a car, and now we're going to look at the friction involved that allows the body to rotate. And so there's going to be some other examples later on where we deal with friction of things that are rolling and things that are rolling down an incline and so forth. But here we're going to take the example of a car that's being driven by the friction, or that's being pushed, I should say, because friction doesn't actually drive, it's the driver that drives, but the friction pushes the car forward and accelerates the car forward. So how does that really work? Well, we have a drive shaft that translates the energy and the force of the engine to the differential that then goes out to the axles of the car. So basically, I should have said the force from the axles instead of the drive shaft. And so the axle then pushes the wheel forward by making it rotate. So you have the axle that's positioned like this on the wheel and turns the wheel forward. So there's a force from the axle of the car going to the rear wheel, if it's a rear wheel drive car, and that makes the whole tire rotate. So let's say that there's no friction between the tire and the road. What would happen is, well, the tire would simply spin around like this. Since there's no friction, there's nothing to make the car move forward. The wheel would just stay in place and just keep rotating. That's what happens when the car is stuck on an icy road. There's no friction, or virtually no friction between the tire and the road, the ice, and the wheels would just spin. So what keeps the wheel from spinning is if there's friction between the tire and the road, then it keeps it from spinning, and so the friction pushes in this direction. And that is the force that actually drives the car forward, that makes the car with a mass m accelerate acceleration a. So how much friction is there between the tire and the road? Well, the definition of friction is the normal force times mu. Of course, what we have here is we have the force pushing down. Now, how much force is pushing down? Well, it's not the whole weight of the car, because the car is sitting on four wheels. If you just simplify things a little bit and assume that the weight of the car is equally distributed among all four wheels, all four tires, then of course the weight pushing down would be equal to 1/4 the weight of the car. And then, of course, the normal force would also be 1/4 the weight of the car. So therefore, the friction force, the normal force times mu, which is 1/4 the weight of the car times mu. Assuming the mass of the car is 1,200 kilograms, and let's, for simplicity's sake, just say that g is equal to 10 meters per second square. Close enough. All right. So here now you also have to think about it. When will the tire slip, and when will it not slip? Now notice that what makes the car accelerate, it's the torque created by the axle pushing the tire around. And of course the torque by definition is the force of the, and instead of D, maybe I'll write A for axle. So the force created by the axle times the distance from the point of rotation to the moment arm of the force. So it would be the small r right there. And the r is usually pretty small, so the force of the drive shaft, in this case I should say axle, the force of the axle must be very large in order to make the wheel turn around like that. What actually drives the car forward or pushes the car forward is the amount of friction you can muster up between the tire and the road. So you want to have very good quality tire in a dry road. So the torque caused by the friction is the friction force times the distance from the point of rotation to the direction, or the moment, or the line of action of the force, which of course is going to be tangential along the tire. So in this case, it's going to be along the road right here. So it's going to be the friction force times the size, the radius of the tire. Now, if the torque caused by the drive shaft is greater than the torque caused by the friction, the wheel will slip. If the torque of the friction is sufficiently large, then the tire will not slip and the car will get pushed forward. Now, even though the tire may slip, you still have the kinetic coefficient of friction, so there will be still some force pushing the car forward, but not nearly as much as when there's no movement between the tire and the road, and then you'll have static friction between the tire and the road. Because remember that as the wheel is rotating around, the moment the tire touches the road, at that point right there, the tire isn't really moving, so therefore there is static friction between the tire and the road at that point. Okay, so let's find out what the maximum friction is that the tire can muster. Well, the maximum friction would be 2 times a quarter the mass times mu, because now we have 2 tires, one on each side. Let's say it's a rear wheel drive, and so therefore the car is being pushed forward by the 2 rear tires. So the total maximum force due to friction is twice a quarter the weight of the car times mu. So in this case, that would be equal to 1/2 mg mu. And so that would be 1/2 times the mass of the car, which we said was 1,200 kilograms, times g, let's say it's 10 meters per second square, and mu we said was equal to 0.6. And so 1/2 times that would be 600 times 10 is 6,000, times that would be 3,600 newtons. So the maximum friction force that can be mustered by the friction between the 2 tires and the road, again is the rear-wheel drive tires, is 3,600 newtons. Well, knowing excuse me, that the force is equal to mass times acceleration, we can then say, so that's force friction max, and we can then say that the acceleration is equal to the mass of the car divided by the force friction max. So the force that pushes the car forward is actually caused by the friction between the tires and the road. So in this case, that is equal to, let's see, the mass would be 1,200 kilograms divided, wait a minute, this is the wrong equation. Something isn't right here. If I solve this for acceleration, it's force divided by the mass, not the other way around, force divided by the mass. So force friction max divided by mass of the car, which is 3,600 newtons, divided by the mass, which is 1,200 kilograms, and that gives us an acceleration of 3 meters per second square. So that would be the maximum acceleration that this car can provide because of the friction between the tire and the road. So the better the tires, the better the acceleration of the car. Now, of course, there's a limit as to how much power the engine has to drive the drive shaft, which then, through the differential, the drive shaft will then cause the axles to rotate, and it's the rotation of the axle that will actually make the wheel go around, make the wheel turn. Of course, the power of the engine will limit how much force we can actually push on the, with how much force we can actually push on the tire. So again, if the engine is very powerful, you have a powerful car, you could put up a lot of torque right here, and the limitation then would be right here between the tire and the road. For example, let's say that the car has so much power that it actually makes the tire spin across the road so that there's no longer static friction between the tire and the road, but kinetic friction. Let's say kinetic friction is only 0.4. What happens then is, let me use a different color, then this here would go to 0.4. Then this would only be 2,400 newtons, and then this would be 2,400 newtons. And notice now you only have the ability to accelerate at 2 meters per second square. So if you're pushing very hard on the gas and you have a powerful engine and it causes the tires to slip on the concrete or on the asphalt, then you'll see that the acceleration capability of the car is being reduced by the relationship between the kinetic coefficient of friction and the static coefficient of friction. And so there you see, that's how things are being driven forward by the friction between the road and the tires. That's how that works.